Thanks, John. Yes, as John said, I'm retired from Oman RF, so that allows me to travel and do binational work to protect the Great Lakes. But every now and then I do take a vacation from my retirement and I do a little bit of fish work. So that's what I'm going to talk to you about today. Title of the talk is Fisheries Management Implications of Lower Trophic Level Change, Development of a Conceptual Model. And I first want to acknowledge my co-investigators on this, Andy Todd, Brian Waddell, Lars Rudstam, Bo Banal, and Julie Hinderer. And also, as you see in this picture, contributions from many other people that contributed ideas and feedback, and as you'll hear, we got together in a workshop that started to develop some of these ideas. Just a little bit on the issue. We've seen a lot of talks in the last few days on lower trophic levels. And in a fisheries context, this just means nutrients, phytoplankton, zooplankton, mysis, benthos. The issue is that fisheries managers are asking for a better understanding of a lower trophic level change and how to account for lower trophic level change in updating FCOs, managing stocking, predator-prey balance, native species restoration, fisheries production, and communicating effectively with clients and partners. Today, what I want to talk to you is the development of the conceptual model describing the influence of lower trophic levels on fisheries, focusing on a little bit on the process we use to develop the model, elements of the model, and potential applications and next steps. So I mentioned a workshop. That was the sort of core of our model development, but it started with scoping of issues with lake managers. And I think it was 2 years ago at this meeting, I just pigeonholed as many lake managers as I could and senior people at the lake levels that were dealing with policy, and just asked them, what are your issues with respect to lower trophic levels? Why are you interested in this subject, and what bothers you about it? And back and forth with the co-investigators and those discussions, we came up with 3 themes that we thought we should investigate that would be useful for fisheries managers. And those were water clarity, nutrients and fish biomass, and food web structure. So based on that kind of preparatory work, we held an expert technical workshop at Shackleton on August 28th to 30th in 2017. And at that workshop, emphasizing these themes, we summarized hypotheses and case histories relating to lower trophic level change and fisheries. I should say, and it doesn't say it on the slide, we focused on sort of the last 20 years. We didn't look back much further than that. And it was at that workshop that we proposed elements of the conceptual model. And then, again, working back and forth, we refined with those concepts with some post-workshop discussions and synthesis. I think it's important to talk a little bit about this slide, which shows what I call the structure of the project. As John mentioned, this project idea really came from the newly formed or newly constituted Science Transfer Board. And there was a little bit back and forth between myself and the Transfer Board to try and scope the project. And then quickly an ad hoc steering committee developed, which was John Detmers, Andrew Muir, Julie Hinderer, and Andy Todd. And them working with the co-investigators, it was more of a collaborative effort here. So it wasn't like we just set out with we had a set of objectives, but the approach was always collaborative and development and co-developed as we went along. And of course, there was a lot of interaction between the co-investigators and a lot of the workshop participants. So it was a unique model that way. So we're all in this together. Well, what do I mean by a conceptual model? I keep throwing the term around. It's a hypothesis or set of hypotheses. They're well supported by observation, but also informed by expert opinion. And it's intended to describe relationships among key system variables in a way that's easy to understand and communicate. It's intended to aid decision making, and because it's a hypothesis, it should be testable. And so there was a lot of scribbling on whiteboards at the workshop, and I'll get right into what we come up with. The conceptual model really starts with recognizing a strong relationship between nutrients and total fish biomass. But there's a lot of variation on that relationship, and variation tends to increase at higher levels of nutrients. We also recognize something we call modifiers that act and interact at the food web, fish community, and species level to modify and influence the variation that you see in this relationship. We come up with 3 categories of modifiers, call these traditional and familiar, transparency as a ubiquitous modifier, and food web structure. Let's look at the traditional and familiar. And what we're proposing, or a way to look at it, is even though we are, this is an overriding relationship which is driving a lot of our fish potential, a lot of the things we work on, from spawning habitat, understanding recruitment, managing predation, managing harvest, external factors like temperature, they can all influence what we realize in that fish potential, fish biomass potential within that envelope of variation. So that really fits our traditional management activities into this overriding concept. A second major modifier is transparency. As we heard yesterday, Lars presented some material that was similar to this, showing how across the Great Lakes and some of our embayments, we're seeing transparency increase. So it's become a dominant feature of the Great Lakes. It, again, acts at the species, population, community, and food web levels. It's a ubiquitous influence, but unfortunately it's not well understood. This is a graphic, simplified graphic. There was a more complicated one, but this tries to make it a little simpler. Acting through water clarity, acting through things like feeding behavior, changes in distribution, habitat change, including benthification, catchability, and vulnerability, we see it affecting lower trophic levels and fish community composition and fisheries assessments and fisheries. So it's a very complex response that's going to take us a while to understand. I highlighted benthification here in red because it's one fairly well understood phenomena that occurs. It's occurred in Bay of Quinte and Ida Lake and parts of Lake Erie, where we see a fish community response. We see a whole systems response in response to reduced nutrients and increases in water clarity, where we shift from a phytoplankton-dominated system to a more macrophyte-dominated system, and we see a very abrupt change in fish communities to more centrarchids and sockets. So that's a fairly well-documented transparency modifier, but we need to do a lot more research on how transparency really affects and modifies this relationship. And the other important thing here is it influences fisheries and fish community assessments through changes in catchability. And we do a pretty good job of adjusting some of our catch at age models, trying to deal with catchability, but we still don't quite understand that completely, and we do see changes in fishing behavior as well. So it's another factor. The third category of modifiers is food web structure. And one indicator that we developed was trophic transfer efficiency. Trophic transfer efficiency is a measure of the efficiency of transfer of lower trophic level production to higher trophic levels, such as fish. And if you take the simple trophic pyramid where we've got our trophic level 1, algae, organic matter, and as we move up to higher trophic levels, we are moving through the species distribution from zooplankton and mysis up to small prey fish, predator fish, and large predator fish. And the indice that we decided to use to measure trophic transfer efficiency was using a series of food web models that organized species groups, diet, and biomass in a way that allowed us to estimate production at each trophic level. We just simply calculated the the efficiency of transfer from trophic level 3 to trophic level 4 and 5 combined. Essentially, prey fish to higher levels of predator fish production. And when we did this across 14 measures across the Great Lakes, different time periods, we found that this averaged about 9%. And that's very similar to the number you see 10% out in the literature for a general trophic transfer efficiency. So it's also kind of nice that way. But when we looked at the individual lakes, we saw quite a bit of variation. So there's our average of 9%. But when we look at Lake Erie, Lake Ontario, and Lake Superior, they're sort of at or above the average transfer efficiency, where Lake Huron and Lake Michigan are below the average transfer efficiency. And you see Lake Huron here being quite low. Well, how do you put that into the context of the conceptual model? Well, here we are with this dominant relationship, but you can imagine that if you have a low transfer efficiency in a food web structure that offers low transfer efficiency, you're going to be down here, so you're not getting as much fish biomass for your level of nutrients. Where at the same time, if you've got high trophic transfer efficiency, you're getting more fish biomass for your same level of nutrients. Another food web metric that's related to trophic transfer efficiency is a indice called primary production required. You can also think of it as primary production acquired, because it really measures, determines from, again, food web analysis, measures how much of the overall amount of trophic level 1, algae and settling dead organic matter, is transferred to specific fish species. So if you look at this little graphic here, we've got all this algae and organic matter, and that represents potential fish biomass. Here's our trophic transfer efficiency, which is sort of a food web, global food web metric, which really tells us, you can measure sort of the total amount transferred. But then there's individual species here, which again, due to the way the food web is expressed, will be able to acquire more of that primary production. And when we look across our models, across the Great Lakes, we see strong correlations between this metric, primary production required, and fish biomass. And you have to do this by kind of a guild kind of analysis. But I want to say it's not, I don't want you to focus on the graph or focus on the points. It's really the idea that food web structure can influence the pathways that effectively transfer available primary production to our species of interest. And when it's working for us, we're getting the biomass of our desired species. When it's not working for us, we're not getting the biomass of our desired species. So the concept's more important than the graph, although the graphs are quite interesting and defensible. So to put that again on our conceptual model, if we were in this zone here, you're just going to be able to sustain more biomass, more biomass with high PPR species. Your food web, again, is being expressed and being exploited, if you will, by this species, so that it's able to acquire more of the primary production, and not being so well exploited or expressed by this species because it's not getting the primary production. And you can imagine in your lake what that might represent. You know, we don't see primary production getting to whitefish, for example, in Lake Huron. We see a lot of primary production getting to gobies, right? So you can start thinking about how food web structure affects how effectively primary production is used. So this is kind of a summary. So what I want you to think about is, given your lake, you know, where are you on this trajectory here? And if we think of, you know, in most of our lakes, we're heading down this trajectory. And that's generally bad news. You've got bad news to offer your constituents. You're saying less nutrients means less fish. But in a more constructive way of looking at it is, you can say either we can modify, we're not a slave to this relationship, we can modify it and try to extract as much fish, desirable fish biomass out of these systems, again with maybe some of our traditional and familiar management activities like habitat protection, species restoration, stocking, exploitation management, you know, trying to maintain our food web structures by avoiding other invasives. On the other hand, sometimes we can't really do much about things, but at least we have maybe a way of explaining some of the changes we're seeing, right? So it won't always be about, oh, we can fix this, but at least we have maybe another way of a context for explaining some of the things that are happening in the Great Lakes. So that's our hope, that this might help in some ways, and we played a little bit with that. We did do a little fact sheet for Lake Huron, sort of a mock-up fact sheet, where we tried to apply some of these concepts and talk about Lake Huron. It's sort of an example of how we might do it. And it wasn't a finished product. We hadn't really ground truthed it, but it was kind of an illustration, and it was pretty well received by the Council of Lake Committees. And so they've asked us to actually maybe work a little harder on something like this, and that's one thing we're gonna do. We've just initiated a project to try and take elements of this conceptual model and see if we can help have a constructive conversation around what's happening in Lake Huron in terms of ecosystem change and what our response might be to that. So we're hopeful there. We also think maybe we can apply these concepts to updating FCOs and rehabilitation plans, and maybe including language around water quality and nutrients. We don't see that in our documents, but maybe we should. And I think it does give us a context for fish habitat and fish species restoration. But as any sort of investigative project, we did get a lot more questions than we had answers, and I think there is a need to promote more food web level research and certainly more transparency research. And I will update you here that Bolbanel is leading a collaborative group that is working on a review paper of transparency, and we may see some research priorities, for example, come out of that kind of synthesis. So I'll leave it there. Just some additional acknowledgements to the Science Transfer Board, John Detmers and Andrew Muir.